infinity. Let's do the positive infinity first. Now, what I just said was the degree of the denominator is greater than the degree of the numerator. This limit should be equal to 0. Now, how do you, because this is increasing faster than this one, and these things will go to 0. If you take a big number for x and square and add 1, and then you take that same big number here, what happens is this will get smaller and smaller and smaller. When x is 2, you're going to get 2/5. When x is 10, you get 10 101s. And when x is 1,000, you're going to get 1,000 over 1,000,001. It's getting smaller and smaller. As long as the degree of the bottom is greater than the degree of the top, this limit will be 0. But there's a way to prove it. Here's what we're going to do. Watch this. What I'm going to do is divide the numerator and denominator by x squared. I'm going to divide the numerator and denominator by the highest degree that we have in the numerator or denominator. That's the x squared. When I divide the x by x squared, I'm going to have 1 over x. When I divide the x squared by x squared, I got 1. And when I divide the 1 by x squared, I get 1 over x squared. Now, as x goes to infinity, this guy is going to go where?
0.
Thank you. This guy is going to go where?
0.
Thank you.
And then we got 1.
And then we get 0 over 1, which is equal to 0. Okay? So as long as the denominator has degree greater than the degree of the numerator, that's going to go to 0.
So the bottom has to be bigger.
Yes. Yes.
Okay.
What if the top is bigger? Let's take a look. Let's take a look at this. Here's the one where the top is bigger. What do you think? What's going to happen here? Going to infinity. That's correct. Very nice. And let's do the same thing. Let's divide and see what happens. Divide, yes.
Oh, no, keep going. It's just something I have a comment.
Okay. You want me to keep going?
Yeah, then I'll say it.
Okay.
Because I just refreshed my memory.
Okay. I'm going to divide numerator and denominator by x squared. Okay? I'm going to get a 1. Divide by x squared. Divide by x squared. Now, this is stuck at 1. It's not going anywhere. What happens down here? As x goes to infinity, this is going to go to 0. As x goes to infinity, this is going to 0. We have a denominator heading towards 0.
That's
It's undefined. That is correct. And this is going to go to infinity. Okay? It's going to increase with that bound. That limit will not exist.
Okay,
Go ahead.
question. For the one right before that, you divided by x, right?
X squared.
Why x squared though?
The biggest exponent. You want to divide by the
Oh, you
highest
always
exponent.
divide by the-
Always by the highest
Okay,
exponent.
okay.
You want to get all your x's in denominators. So those things will go to 0 for you. Okay? That's what you want to do.
So let's say that they have the same number.
Ah, the same degree.
Just divide the leading coefficient.
Yeah, ooh, that's right. That's where I'm headed. That's where I'm going right now, Danny. Let's do it. Third case. All right, let me just summarize the first two. Denominator greater degree, limit 0. Got a horizontal asymptote. Okay? Numerator greater degree, it's going to go to infinity. No horizontal asymptotes there. That function is either going to go to positive infinity or negative infinity depending on the signs. Okay? Let's do equal degree. Let's take a look at this one. Same degree. Let's divide numerator and denominator by x squared. You get a 2. You get a 3. You get a 10 over x and a 7 over x squared. Okay?
You divided by 2?
I divided by x squared.
Oh, because it's the biggest one.
That's correct.
Okay. Why not 3x squared?
Because I don't care about the 3. I only care about the variable to the highest exponent. The 3 doesn't help me out.
Okay.
Probably just makes things more complicated.
Yeah, that's true. Where's this guy going as x goes to infinity?
0?
Where's this guy going as x goes to infinity? What's my answer?
2 to
So
2/3.
whenever the 0 is in the numerator, it always goes to 0.
2.
When it's going to infinity.
Correct, yeah, all right, I agree with that. And when it's in the denominator, it's gonna go to infinity. And when it's neither, it's gonna be some limit. And what is that limit if you have the same degree? It's the ratio of their leading coefficients, 2/3.
So this is y equals 2/3 is the asymptote.
That's exactly right. Horizontal asymptote, good call.
And DNA doesn't have a horizontal asymptote.
That is correct, D and E. All right, we got a couple more to do. We're almost it, though. This is almost it.
If we keep doing.
Melissa, what are you doing? What do you got? We got places to go and things?
My bad.
Oh, you're bad.
Date.
Hot date. All right, let's not pursue this. All right, let's see. Horizontal asymptote is y equals 2/3. Now, we got a couple other possibilities. So far, we've talked about these rational expressions here, okay? Well, what happens if we don't have a rational expression? Let's suppose we throw a Turing function in there for laughs, okay?
Yeah, well, really, that.
Yeah, you're funny.
So fun.
Let's take a look. Now, here's the deal. We know what happens to sine x over x as x goes to 0. That limit's equal to 1. We proved that. That was a proof we did. Sine x over x, x goes 0. What happens as x goes to infinity, on the other hand?
It goes to 1.
No. What's that?
DNA.
Carolina has? What is it? No. What
As it
happens?
goes to infinity, right? You said.
X is going to infinity.
Okay, so you divide both of them by each other again?
Well, that's not going to help. Watch what happens if you divide by x, say. You get sine x over 1, which is sine x over x. You're back to where you started. And dividing by sine x is not going to help either, as far as that goes. Here's what you do. Here's what you have to think about. This numerator is said to be bounded. It's going to be 0. It's going to be 0.
Definition about it, what is it?
Bounded means it has an upper boundary beyond which it doesn't go. See, sine x is bounded. Here, let's take a look. Here's sine x. It's bounded above by y equals 1. It never gets beyond that. And it's bounded below by y equals negative 1. It never goes below that. It's bounded. It's stuck between those two boundaries. Okay? X, on the other hand, is not. It will increase without bound. Okay?
Unbounded.
It's unbounded. That is correct. What happens if you were to put in a whole bunch of values here and let x increase? This thing would always be between negative 1 and 1, but this thing would increase without bound. And what happens to the graph is you would see this happening. The limit at 0 is 1. It's technically undefined, but the limit does exist. It would look like this.
So like, oh,
Is that x?
That's weird.
That kind of looks familiar.
This is sine x over x.
Oh yeah, that's where it just there's a thing.
There's an oscillating function that gets smaller and smaller and smaller. And what's this limit equal to then? As x goes to infinity, that limit is 0. As long as the numerator is stuck between two values, and as long as the denominator is increasing without bound, that limit will be 0.
Are you going to do one slash? Oh, I'm sorry.
No, that's all right. Go ahead. Go ahead.
Why does sine start at 0, 1?
Well, you notice I got an open circle here. It's undefined there, but the limit is equal to 1 as x goes to 0. This limit we proved.
Sine starts from 1, right? All the time.
No, sine starts at down here. Okay. We proved that limit's equal to
That's
1.
cosine.
So the limit's equal to 1 here at this value, but it is undefined, so there is a hole there. But the limit does exist. Because, all right, let me ask you this. All right, here we go. Because the limit exists, and we have a hole there, is the function continuous at this point? No, it's not continuous. It's not defined. Is that a removable point of discontinuity?
No. Yeah.
Yes, it is. Because as long as the limit exists, which it does, we could fill in that point with 0, 1 and make it continuous there. I just thought I'd throw that in there. No? Okay, what else should you know about these things?
You do another trig one?
Trig one? Sure.
Like tangent.
All right, do a tangent.
Second me in the back.
Well, what, is cosine gonna be on it or tangent?
Maybe both, maybe neither.
Okay, so.
But sine for sure, but we have a couple other sine ones to do.
Oh,
Wait a minute, no, we already did those. Sine 2x over x, we already did all those.
wait, can we do that? No, I forgot.
You forgot? All right, I'll do it in a minute.
2x over x?
Yeah, let's do a tangent one.
Give me that look like. He's
What?
mad. He's mad.
Who is?
Because we're staying longer.
Vitaly,
Because I.
no, Vitaly's very laid back. He wouldn't get mad at you.
Never
His
gets
face,
mad.
You wanted to beat me up?
Ever.
What's
Oh
that?
my God, like you wanted to beat me up?
Oh, Vitaly?
Yeah, he was like.
No way. No way, I don't think so. Look, he's holding his heart because you're making him, my heart, man, what are you saying about me? Let's take a look at this one. Tangent x over x. Oh, let's just do tangent x. Let's just do tangent. As x goes to infinity, what's the limit here for tangent?
As x goes to infinity?
Yeah.
Is it 0 2?
No,
Is it 1?
Infinity.
no.
Is it D&E?
It's definitely a D and E, and you can't even say infinity. Because it keeps on repeating. It just keeps on repeating. It doesn't approach any one limit.
Once
you
you
prove
said
it now?
yes, then I said.
Oh, all right. What's the limit here? What's this limit? X goes to infinity of sine x.
Sin
Danny
x?
was 0.
Danny! Thank you, Danny. Hey, this is almost you too. Wow, Danny, Danny. Wow, that's pretty close. All right, anyhow. What's that? Yeah, because it's repeated. It's periodic. It's not approaching any one value as x goes to infinity. Okay? All the trig functions are D and E's when it goes to
Are
infinity.
there any ones that go under infinity and they equal 1?
Not for the trig functions. No,
Okay, okay.
none.
How about non-trig functions?
Yeah, of course. You ready for one? But you guys could come up with one. Here's what Nick wants. He wants you to define a function whose limit is 1 as x goes to infinity. Can someone accommodate him?
1 over x.
No, that goes to 0 as x goes to infinity.
How about x squared over x?
Over what?
X.
No, that goes to infinity as x goes to infinity.
Oh, I'm sorry.
That's okay. What is it?
The limit is y over x. Y equals 1.
X over x, that works. That works, x over x works. How about
Y equals 1 or something?
1, have a 1 here, that works. How about this? How about
Something
this?
more complicated.
Here, how about this?
Oh,
That limit is 1. Why? Because degrees are the same. And what do we say? If the degrees are the same, it's the ratio of the leading coefficient. You divide by x squared, you'll end up with 1. Okay?
Now that's the vertical, not the vertical, horizontal asymptote.
Yeah. Okay, I'll go, one more problem I got, because I believe in course on WebAssign they do this.
what do you mean, one more? No?
I'm going to give you one. Yeah, we're done. That's it. Okay?
We have to all get it right? Or like 6?
Oh, yeah, that's it.
I just
Whoa, that's a good one. No, that's good. No, that's
You're gonna be
good.
stuck here
These are so easy, it's not fun. No, you're not. Here.
stop forever.
Now he's mad. Now he's
No, it's just,
They give you, I wasn't even thinking of that, because the WebAssign one has a problem like this. They have,
well, if it's too hard.
no, well, it's not that. They give you a problem, and then they say, it's over like a g of x.
What?
And then they say, well, find the limit if g of x is equal to x cubed. And find the limit when g of x is x squared. And find the limit of g of x if g of x is x. Okay? And we might as well do one more. What the heck? G of x is equal to, let's say, 10.
We can't get all like of them right.
There's 4 of them. Okay, now here's what I want.
I'm not getting what you're getting at here.
I want 4 different answers. I want the limit of this when g of x is x cubed. What's the limit as x goes to infinity? When it's x squared, what's the limit as x goes to infinity? When g of x is x, when x goes to infinity. So I want 4 different answers. And I need 2, 4, 6, 8, 10. We got 11. 6 people get it right. And then we go. If we can't get 6, you got 1, you got to get all 4 right. If we can't get 6, we're going to do another one, and I'll have to crank it up a little bit and have fractional exponents and throw some exponential functions in there and log
And
functions.
absolute values, you get,
Oh, some absolute
it
values
is
in
absolute
there.
values. Can Can you do one of those after?
Nah, we don't do it. There's no absolute value ones in there.
Are you sure? Like an
I'm not sure,
absolute
but
value
I-
that goes to infinity.
Yeah, I could do one, but we could do one. Here, okay, 4 answers. You're writing down all 4 answers. Raise your hand. You got 1 shot. We need 6
So
people.
pretty much you're just finding the
The 4 limits.
asymptote.
Yeah, find any horizontal asymptotes if they exist.
I'm ready for you.
No. Oh, wait. Oh, that's your limit. Okay, that. Perfect. 1.
That's it?
We got 1. We need 6.
It's just like what we've been doing the whole class.
I know.
It's the same thing.
2.
Yes.
Good job. 2.
Good job, thank you.
He's laughing. He's sneering at this question. He said, this question's too easy for you.
Right?
We got 2. Come on.
Guys.
Don't give no hints. You can't give any
What
hints.
do you mean? I'm just holding.
You're giving them
Yeah,
hints.
this? What does this mean?
That
It's
means
not even an
something.
answer.
I don't know. I'm not up on all the
Thanks.
current stuff. Like I was told today, don't curve somebody. I didn't know what that he was talking about.
I don't know what they're talking about either.
What kind of
I
curve?
mean, I go to high school and I've never heard that before.
You
Oh.
didn't hear curve? Oh, I had you?
You're
Wow.
ahead of me.
Don't curve me. It used to be don't play me, but now it's curve.
Curve, I don't know.
Yeah. That's enough. We got 2. Uh-oh.
Take your time, guys. I think we're good.
You think so? You got faith in these guys?
Well, 3 more get it wrong. Then I lose faith.
All right. We need 6. We got 2. And then Thursday, we'll finish up on the graphing thing. Thursday should be pretty simple, too. And then we'll do the max min problems. Your test will be, like I said, whatever it is, the 24th. Your answers are this, there. We still have 2. Oh, we lost track. Ooh, that's a big one.
No.
One more. Okay, we got 2 right and 1
Come on, guys.
Ooh, lose track. That's the nature.
Nah,
You may be here.
I don't count, remember?
No, you count.
You do. You get hundreds on like all the tests.
Yes,
You
you
get
count.
counts.
You count.
Well, everyone counts.
Well, what he's referencing is his math team performance didn't count because he already has a degree from somewhere. And that's, if you have a degree from somewhere, it doesn't count as a math team. You can't have a degree from
Were
anywhere.
any of them right?
Yours? In the math?
No,
Yeah.
these.
Yeah, 3 out of 4.
The last one was wrong?
No, last one's okay. No, actually, 2 out of 4.
What?
Yeah, it's 2 out of 4. You got 2 wrong. All right, we got 2 right, 1 wrong.
I just get nothing right.
What do you think? Oh, you lose your faith?
No one
We
looks
gotta
like
have to
the.
do another one?
Everyone looks blank.
I know, they don't look too good. Even Vitaly looks stumped.
Yeah, he's been doing Mathematica the whole time. He's
Oh, he hasn't been listening to me.
Yeah.
Oh, I see, that's what it's about.
Ooh, she's just causing
Boy.
Come on, let's
Here we go. Chris?
Please.
No! Whoa, 2 to 2 still. I mean,
boy.
still 2. It's your last one, that's right. This here?
No.
2 right and 3 wrong. Oh, we lost the tally too. This is a disaster.
Okay, hell with this.
Nick?
That, and that's it, I think.
We have 2 right and 4 wrong. We're doomed.
Yeah.
We're doomed.
One more time, we should go over it.
What do you got for answer?
None of it got it right, but whatever.
We have 2 right and 5 wrong. Chris has got it right now, but it doesn't count. That? Oh, no. That one's not right there. Doing it fun. Let's do it. If we go, if 4 people get it right, we can still do it. And we have 4 people still eligible.
Oh, I don't know.
1, 2,
Was I way off?
3, and you're out,
Okay,
and you're
so let's
out.
go.
Let's do it.
See, it would have been bad if we just left it.
I know, you're right. You're right. You're right. You're absolutely right. You are helping. That was very good. Okay, first one, limit. X goes to infinity, okay? X squared plus 3x plus 1 over x cubed. The degree of the denominator is greater. Therefore, this is going to go to 0. As soon as that's greater, it's going to go to 0. Okay?
I got that one right.
Okay. Now, x goes to infinity.
It's only in the.
X squared plus 3x plus 1 over x squared. Same degree. Ratio of the leading coefficients is equal to 1.
Why again?
Because if you divide everything by x squared here and then by x squared here, you're going to get a 1 here, you're going to get a 3 over x, you're going to get a 1 over x squared, and you're going to get a 1 again.
Wait. Oh, okay, that's what I did wrong.
Next one, limit as x goes to infinity.
Wait, can you go back to that one again?
Yeah.
I'm sorry. 1 plus 3x, 3 over x over 1 over x squared. How is that 1?
Okay, you divide numerator and denominator by x squared.
Yes, I got
That will give you a 1, it'll give you a 3 over x,
Yes.
and it'll give you a 1 over x squared.
Yes, how does that
This will
top-
give you a 1,
How's that top part 1?
because this will go to 0 as x goes to infinity, and that will go to 0 as x goes to infinity.
So it's like it's like a thing in a thing. What is it called?
Yeah.
Thing.
It's like to the U type thing, right?
Well, I don't know. If you got a numerator that's a constant and a denominator that's a variable going to infinity, that limit will be 0.
Okay.
Hey, Vitaly got it right.
No, he didn't.
Did, definitely.
The third one,
Just trying to make
x.
it better now.
X squared plus 3x plus 1 over x. Degree of the numerator is greater. That's going to go to infinity. And the last one,
With
Hey.
D&E.
or D&E. I'll accept D&E.
I put D&E, I don't know.
That's fine. And the last one is divided by 10.
Did you actually just plug it in?
What?
Did you just plug it in?
What?
You
Where?
plug it in, don't you plug 10 in for?
No, you don't have to do anything. This 10, all that does, that makes this a polynomial. And what did I say about polynomials? They're going to go to infinity or negative infinity. They never have limits. This is equal to infinity or D&E again.
Hey, what's up with that other infinity sign? It's 3 circles.
Where?
What are you talking about?
Oh, yeah,
Infinity.
that's right.
Yeah.
I don't know what that is. I gotta give it, we gotta do another one.
Okay, let's go.
There we go.
Come on, guys. We know what to do.
Told you would be here for another hour.
All right, here we go. Limit,
Fine.
x goes to infinity. We're gonna do 3x squared plus sine x plus 7 over g of x. Okay. We're going to find g of x, find the limit when g of x is equal to 4x squared, when g of x is equal to 4x, and when g of x is equal to 4. Okay? I should have given you an x cubed one. And g of x is equal to x cubed. I have to give you that too. I have to give you the x cubed one. There's the 4. This is number 1, 2, just so we keep it straight, which is which? 4. Okay?
You just plug those in, I'm guessing, right?
Well, you got to look at the degrees and determine it from the degrees. Okay?
Oh, it's over, g of x, okay.
Yeah.
Where did that come from?
Okay, I need 6 people. Let me think what this one is.
Wait. Here. I switched around because I only have one first.
Oh, yeah, me too. Okay. Okay, so the first one is, okay, first one is this one here. Okay, that's correct. That's correct. And that's correct. And now okay, so number 4 now is that's correct.
You know,
All
I'm
right,
out of issues, but what do I do?
All right, no, you got it. We got 1. Oh, wow, golly. We got, so you're doing, your number 1 is my number 1, right? Wait, oh, there it is. Oh, I had my finger over it. Your number 1 is 1. Oh, no. We got 1 to 1 here.
Why would you put it?
Oh,
No.
Dropping like
flies.
I think that you was like.
That's correct. That's correct. That's correct. And that,
Yes.
2 right.
2.
Away.
Good job, thank you.
Ooh, pressure.
Yeah, you're tired.
Okay.
All right, here's Nick.
Oh, he's got it. He's got
Let's
it.
see if I got it. Is that it?
That's correct. That's correct, that's correct, and that's correct. We have
Yes.
3 right.
3 right.
Woo-hoo. Correct, 4 right. And 1 wrong. We got 4.
How many do we need?
We need 6, we need 2 more. We're doing this problem right here. We need 6 people right, and then we'll be done.
You are being recorded.
Oh, we are being recorded. See that symbol? Whoa. We need 2 more right. We got, Melissa, do you have it?
You poor soul.
No. We have 5 right and 1 wrong. Good job.
So we got 5 right, so.
We got 5 right, only need 1 more.
Okay.
Really? One more?
1 more. We need 1 more.
Okay.
Trent, you going with it?
Come on, Trent.
Right. Right.
Uh-oh.
Wait.
Uh-oh.
4x squared?
Right. Wait, this doesn't look right. How come that?
It's not right.
No, it's, okay, that is correct. This, no, this one is the one that's wrong. Yeah, that one is wrong. We got 5 and 2. We got 5 and 2. It looks good there.
One more person.
We need 1 more person.
Where
Where are we gonna get this person?
I kind of got the hang of
He hasn't done his,
it.
right?
Really just looking at the first one.
Carolina and Melissa we need. We need 1 of you guys.
Oh, yeah, is he one?
Yeah, he's already done. He got it.
Got him.
He's 1 of the 5.
Wait.
Carolina, you have it? Here we go. This is tense. This is tense. Let's see what we got. So your first one is, what did you answer? No.
Oh,
no.
yeah.
Am I doing this right?
Oh, no.
You made the same mistake Patali made.
Divided by x squared.
Well, I just have to ask. That one's increasing faster because it's x squared, and that one can't catch up to it.
6 right. Yeah. Nice job. All right, let's do it. Amy's already out the door. Hold on. Here we go. You ready?
Yes.
It's 0 because the minus.
All right, x goes to infinity,
Good job.
3x squared. Sine x plays no role in this bit being bounded like it is. 4x squared. Ratio of leading coefficients, 3/4 Vitali, not 1, okay? Limit as x goes to infinity of the 4x.
It's less than it, so it's automatically 0.
So it's less than that, so this is going to go to